Hey guys, welcome to brainAttic. So today we have another very interesting and challenging problem from the topic of coordinate geometry, specifically straight lines. This question was asked recently in JEE Advanced 2021. So if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. So in the question, we are given two lines L1 and L2, the equation of which is given to us as x root 2 plus y minus 1 is equal to 0. And for L2, it is x root 2 minus y plus 1 is equal to 0. Now, for a fixed constant lambda, let C be the locus of the point P such that the distance of P from L1 and the distance of P from L2 is given as lambda square. Now, the line y is equal to 2x plus 1 meets C at points R and S, where the distance between R and S is given as root 270. In the second part of the question, we are given that there is a perpendicular bisector of RS which meets C at two distinct points R dash and S dash. The distance D, the square of the distance of R dash and S dash is given as D. Now we are asked to find lambda square and D. So let us begin. So we will first draw how are the equations L1 and L2 actually look like. So L1 is given to us as x root 2, my bad, x root 2 plus y minus 1 is equal to 0. And L2 is given to us as x root 2 minus y plus 1 is equal to 0. Now, if I were to draw this on the xy plane, we will have something like this. Pardon my measurements, it could be very wrong, but it's supposed to give a rough idea. So this point is y is equal to 1, and this line is L1, and this line is L2. The point here is x is equal to minus 1 by root 2, and the point here is equal to x equal to 1 by root 2, which is plus. Now, from the question, we are given that there is a curve C such that the locus of the point P and the distance of the locus of the point P such that the distance of point P from L1 and the distance of point P from L2 is lambda square. So we are going to write the equation for C as x root 2 plus y minus 1 by root 3 with product with x root 2 minus y plus, plus 1 by root 3 is equal to lambda square. Now, if we just solve this equation C such that x root 2 whole square minus y minus 1 whole square divided by 3 is equal to lambda square. This gives us that C such that mod of 2x square minus y minus 1 whole square within mod is equal to 3 lambda square. So we have the equation of the curve C. Now let us assume that the point R be denoted by x1 comma y1 and point S denoted by x2 comma y2. Now, since the curve C cuts the line y is equal to 2x at point RS and R and S, therefore I can very easily say that y1 is equal to 2x1 plus 1 and y2 is equal to 2x2 plus 1. Now, again, very easily I can make a statement that mod of y2 minus y1 is equal to 2 into mod of x2 minus x1. Correct, right? Now, we are going to use this equation into the equation for curve C and we'll try to solve it. So we have using y is equal to 2x plus 1 in curve C since they intersect each other. So we have mod 2x square minus 4x square is equal to 3 lambda square. Now this gives us that mod of 2x square is equal to 3 lambda square. This eventually gives us that x is equal to plus minus root over 3 by 2 mod of lambda. Now this x can be x1 as well as x2. And if you remember this diagram which we have just drawn, then mod of x2 minus x1 has to be 2x. Otherwise it will be 0. So it has to be 2x. This gives us that mod of x2 minus x1 is equal to root 6 mod of lambda. And we already have this equation with us, which allows us to find that mod of y2 minus y1 is equal to 2 into root 6 mod of lambda. Now, the distance of the point, going back to the question, we have that the distance between R and S is given to us as root 270. So the distance between R and S is given to us is 270. So RS whole square is equal to 270. Since this. Now I can very easily write that x2 minus x1 whole square plus y2 minus y1 whole square is equal to 270. Now substituting this x2 minus x1 as 6 lambda square plus y2 minus y1, I can write it as 24 lambda square is equal to 270. This gives me that lambda square is equal to 9, and this is the answer for our first question. What is the value of lambda square? It is 9. Now going to the next question, the midpoint of RS is, if I'm asked what is the midpoint of RS, I can very easily write that this is nothing but x1 plus x2 by 2, comma y1 plus y2 by 2, which is nothing but 0, comma 1. Correct? Now, the slope of RS. You can visualize the diagram to have an understanding. The diagram which we have drawn here will help us very easily whether it is correct or not. Now, the slope of RS is 2. Then slope of R dash S dash will be minus half. So the product of two mutually perpendicular lines, the product of the slope of the two mutually perpendicular lines is always equal to minus 1. Using that concept, I can determine the slope of r dash s dash. So we have the equation of r dash s dash now. Equation of r dash s dash is y minus 1 is equal to minus 2x, minus half x. Okay, this eventually I can rewrite as x plus 2y minus 2 is equal to 0. Now this equation and the curve C do intersect with each other. So solving x plus 2y minus 2 is equal to 0 with C, we have, so if you give an effort and try to solve, you will have a result like x square is equal to 12 by 7 lambda square. Okay, and again using the same idea, we have x2 minus x1 within mod is equal to 2 under root 12 by 7 lambda square. But this time y2 minus y1 is equal to root over, I made a mistake over here. This should be mod lambda 12 by 7 mod lambda, because this time our equation has y minus 1 is equal to minus half of x. So the two part gets cancelled and we are left with 1 only. So if the distance d is to be found, which is r dash s dash square, that is x2 minus x1 whole square plus y2 minus y1 whole square, and this gives me 12 by 7 into 5 into 9. Lambda square we have found to be 9, and this is nothing but 77.14. So this is my final answer for the second question, 77.14. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.